Hello everyone, welcome to Think Global Education Services. Today we are going to discuss a topic from AP Calculus AB, which is continuity. Immediately after learning the concept of limits and its properties and the problems based on different ways of solving the limits, the very next topic is continuity, which is an introduction to the next topic, differentiability. Let us get into the definition of continuity. A function f is said to be continuous at a point C when the below three conditions are met. The first condition is f of c must be defined. Second is limit extending to c, f of x must exist. And if they both exist, the third condition is they are equal, they must be equal. Extending this to an open interval, a function is continuous on an open interval a comma b when the function is continuous at each point in the interval, which means at each point the function must satisfy these three conditions. A function that is continuous on the entire real number line, which is negative infinity to infinity, is called as everywhere continuous function. In simple words, we can say that a function is continuous in an interval if we can draw its graph flawlessly, or we can say that if there is no break or if there is no jump in between, then this function is said to be continuous, which means that learning it graphically makes it much more simpler. Let us look into the first graph. Here we can see that C is a point in between a comma b, an interval, and f is given, the graph of f is provided. Here you can see that at C, at only C, that point f is not defined, which means that the first condition for continuity is failed. Thus we can conclude that the function is not continuous in this particular interval because of this point. And looking into the second graph, we can see that at C, the function is defined somewhere, but immediately after it starts in somewhere else, which means that first condition is satisfied, but the left limit is approaching to some other point and the right limit is not equal to the left limit. Thus the second condition is failed here, and it is not continuous. Looking into the third graph, we can see that the function is defined at C at some point and the limit exists because the left and right limit are approaching to the same point or is the same point, but the limit value is different from the defined value. It is in two different positions, which means third condition fails, which also makes this function not continuous in the given interval. From this we can get the idea that even if one condition among the three fails, the function is said to be not continuous in the given interval a comma b. Now getting into some examples based on this, discuss the continuity of the given function. A graph of a function is provided. We are not aware of what the function is, but the graph is provided. And we can see that the graph from -3, which is considered to be A, and till 1, which is considered to be B, is been provided in the given graph, given picture. And we can see that at -1, at x is equal to -1, there is a break. Here you can see that the function is defined over here, which means the first condition is fine. And we can say that c equal to -1, which means f of -1 exists. Second condition is whether the limit is exist or not. Here the left limit, you can see that it is approaching to the y value or 2, which means limit x approaches -1 from the left side, this function is having the left limit 2, and limit x approaching -1 from the right side, the function is approaching to, we can see that it is approaching to the y value 0. So in total we can say that combined limit extending to -1 f of x does not exist, which makes the second condition failed in this case. As we have already discussed, if one of the condition is failed, then the function can be not continuous in the given interval. Thus the function fails its continuity at x is equal to -1. Now let us look into another example which is provided over here. F of x is equal to x minus 5 over x square minus 25, and we need to discuss the continuity again. Here, if we look into the function, we can say the denominator fails or denominator becomes 0 at x is equal to 5 or -5, which means there is a chance for discontinuity at these 2 points. Looking for f of 5 or f of -5, we are not going to get a defined finite value, which makes this undefined. Thus, the first condition is failed for both of these points, and for every other point, you can see that it is defined. And by solving this particular function f of x, we can get the numerator as it is, but the denominator is simplified to x minus 5 times x plus 5. And it is visible that there is a common factor at numerator and denominator which can be cancelled out, and it becomes 1 over x plus 5. Now what happens is f of 5 is defined, which will become 1 over 5 plus 5, which is 1 over 10, but still f of -5 is an issue. And getting into the limit of it, limit x approaches 5 f of x. Here that exists and is equal to 1 over 10. But what happens if limit extending to -5 is to be found? That is not possible, which makes this does not exist. So what happens here is the problem caused by x is equal to 5 is been removed after the factorization, which makes x is equal to 5 a removable discontinuity for this function. And what happens to the next point, x is equal to -5, there it is not removed, or the problem caused by that particular point is not removed. Even after simplification, we are getting an undefined value for f of -5, or the limit is not existing, which makes this a non-removable discontinuity. Thus, what we can conclude is f of x is not defined at these 2 points, or f of x is not continuous at these 2 points, but at x is equal to 5, the name of the discontinuity is removable, and at x is equal to -5, the function is having a non-removable discontinuity. Or in other words, we can say that if a particular factor is cancelled out on the numerator and denominator, here it is x is equal to 5, which makes this function defined at that point after cancellation, which means at that point a function will be having a removable discontinuity and the other point will be having a non-removable discontinuity.